By request, this is HRW98P002, the roller coaster problem. So it says, in the figure below, a frictionless roller coaster with a mass of 537 kilograms tops the first hill, right here, with a speed of 4.1 meters per second at a height of 27 meters. So first it wants to know how much work does its weight do on it from the initial point to point A. Well, if it starts here, point A is here, it's true that it goes down, and then the weight would be doing positive work, but then it goes up. So the weight would be doing negative work. In fact, in the end, the work done is zero because it's at the same height. One way to look at that is we did that equation in class. Basically, the work done by gravity, remember this is the one that only WebAssign does, they never ask for this on the AP test really, equals the negative change in the potential energy. So basically negative mg change in height, while from this point to this point the height doesn't change. It's the same height. So I'd end up with a 0 right here, which means I'd get a 0. Okay. Then it says, how much work does its weight do on it from the initial point to point B? Okay, that's a little more interesting. So if we look here, use this equation. So the work done by its weight, by gravity, basically, from the initial point, well, so the work done by gravity is negative mg delta h. Well, it starts off at a height of h. Okay, that's 27 meters. Okay, 27. And it's going to change down to point B is half of that. So half of 27 is, let's see if I do them in the head, 13.5? Yeah? So the change was 13.5. Okay, so we get negative mass is 537 times g times 13.5 should give us the answer. I did this backwards, didn't I? I did it backwards. To find a change, you always do the second value minus the first value. I'm an idiot. I'm sorry. So, other way. Oh my goodness. I just got back from a movie and my mind is not here. So this would be negative, which means negative times negative is a positive, so I'm going to end up with a positive, and I get, my calculator says 71,045.1, but we didn't get, I think the least sig figs we got was 2 sig figs. So that's why in the answer on the key, there's only 2 sig figs here. So like my calculator says this. This is what my calculator says. But remember what I said in class? You don't just keep writing all the digits because you gotta stop somewhere. You might as well stop with significant figures. There's 2 in my given data, so it really should just be 2. So I need to round to 2 sig figs, so that would be 71,000 joules. That's why the answer is 71,000 joules. Okay, how much work does it do on it from the initial point to point C? Well, from here to point C, I drop the entire 27. So basically, same exact equation, but instead of 13.5, it's 27. Basically, I'm going to double this number, so I'm going to be double this number, okay? Negative 537, 8, and it changes by negative 27 meters. Okay, basically I get double this. So that's 142. Let's see, 1, 2, 3, 4, 5. Okay, let's see. You double 71 and you get 14.2 with the zeros. Anyway, joules. Okay, now we've got the gravitational potential energy of the coaster Earth system is taken to be 0 at point C, so at the bottom. What is its value when the coaster is at point B? Well, that's... Oh, gosh. I should use the roller thing. Okay. Well, at point B, I am 27 divided by 2 meters above what's taken to be 0. So that would mean that the potential energy, gravitational potential energy is mgh. So 537 times 9.8, actually I like parentheses better, let's do that, times 27 over 2 is 13.5. Hey, we've done this before. That's what this one was. So, same answer. That's why the answer is also 71,000 for part D. At point A, same thing. It's the same equation with the height difference being 27. That's why I get the same answer as point C. Now, if mass were doubled, would the change in the gravitational potential energy of the system between points A and B increase, decrease, or remain the same? Okay. Well, if mass is doubled, when I go look at my my equation, if I, let's see, here we go, mgh. Well, if I double m, then I double the whole thing. So it would also double. So increase is the correct answer.